Welcome back to Awesome Agents. Today we're talking about a headline that dropped this morning. Mira Murati's lab just chose its first cloud provider, and it's Google.
Yeah, Thinking Machines Lab signed a multi-billion-dollar deal with Google Cloud for GB300 chip access, their first formal infrastructure commitment.
So context first. Mira Murati is the former OpenAI CTO. She started Thinking Machines Lab about 15 months ago, and the lab has released nothing publicly so far.
Nothing, no models, no benchmarks, but in the last 6 weeks, they've made two enormous compute commitments.
Right, because back in March, NVIDIA committed a gigawatt of compute directly to TML. That was a separate deal.
A gigawatt of AI data center capacity maps to hundreds of thousands of high-end GPUs. The Google Cloud deal adds a managed cloud layer on top of all that raw capacity.
So what's actually in this Google deal? Just the chips?
Not just chips. Google is bundling storage, Kubernetes orchestration through GKE, and Spanner for databases alongside the compute. It's a full managed stack.
Why does that matter for a lab that's still building from scratch?
Running your own storage, networking, and orchestration separately is a huge operational lift. A managed stack lets you focus on the actual research instead.
And one of TML's founding researchers actually said something about this?
Mila Ott told TechCrunch that Google got them running at, quote, record speed with the reliability they needed. That's a practitioner endorsement focused on operations rather than specs.
Okay, let's talk about the chips themselves. GB300, Vera Rubin generation. How big a jump is this?
It's meaningful, twice the training throughput compared to B200 systems, and up to 30 times faster on inference compared to H100s.
30 times faster on inference. That's not a small number.
It comes from two things: more memory per chip, 288 gigabytes of HBM3 each, and much faster connections between GPUs, 1.8 terabytes per second at the interconnect level.
Why does the interconnect speed matter so much in practice?
At cluster scale, training large models stalls when the chips are waiting on memory transfers instead of computing. Faster interconnect means you can actually use the compute you're paying for.
So why did TML pick Google over AWS or Azure?
Google needed a frontier lab reference customer for their GB300 offering. Microsoft already has OpenAI, Amazon has Anthropic's dedicated Trainium cluster. Google had an opening here.
And Thinking Machines is a high-profile name even without any public models yet.
That's the play. Sign a lab before it has bargaining power. If TML ships a strong frontier model, Google has a very prominent customer. The deal is non-exclusive, so TML could add AWS or Azure later.
But the bundled services create switching costs even with a non-exclusive contract.
Once you're running production workloads on GKE with Spanner as your database, moving providers is painful even if someone else charges less per GPU hour.
There's a lot this announcement doesn't answer, though. The dollar amount is completely vague.
Single-digit billions spans 1 billion to 9 billion. That's an 8-to-1 range. Neither side disclosed the full contract value or per GPU pricing.
And we don't know when they'll actually run on GB300.
The deal is signed, but Vera Rubin isn't fully available at production scale yet. The announcement doesn't say whether that's Q3 2026 or later.
And TML still hasn't shipped anything publicly, 15 months in.
That's normal for a lab in the training phase, but the spending is enormous relative to their public footprint. Both compute deals together suggest truly frontier scale training runs ahead.
So the question everyone is sitting with, when does Thinking Machines actually release something?
And what it looks like when they do. The compute is there, the cloud stack is there, now you're waiting on the model.
That's Thinking Machines Lab picking Google Cloud for GB300 access, somewhere in the billions. We'll keep watching for what comes out the other end.
Yeah, that's the part that actually matters.